I'm Anna Clifton.
I'm Chastity Resch.
And I'm Jenna Duval.
And this is our experiment for the calibration of a wind tunnel.
Since we had to prepare a lab design, we chose to include the objectives and goals that we were hoping to accomplish during the completion of the experimental process. Our first goal was to familiarize ourselves as students with different pressure measurement devices, such as the wind tunnel and the anemometer, and use these devices to understand the calibration of a wind tunnel. Our second goal was to become familiar with the wind tunnel experiment and wind tunnel testing. Our third goal was to measure pressure changes by studying the wind tunnel with and without restrictive plates. Lastly, we chose to compare and contrast the values that were found when using restrictive and non-restrictive plates. The first wind tunnel was designed in 1871 by Frank Winham and became a building block for what is now known as an indispensable invention in the aerospace industry. The wind tunnel was made up of a funnel with a fan blower that propelled air through the body of the wind tunnel. Different shapes were inserted into the tunnel to measure the lift and drag forces on different bodies. The Wright brothers also used a wind tunnel to test their aircraft wings in 1901. Now, wind tunnels are required for aircraft testing. Wind tunnel testing is used to understand the aerodynamic flow and simulate the movement of air around the body. Calculations can be scaled up to accommodate larger bodies such as space shuttles or an aircraft. In the lab that we designed, we used a wind tunnel and an anemometer to study the airflow and velocity. We then used two different types of restrictive plates within the wind tunnel in order to determine the change in differential pressure and how it related to the velocity.
For this experiment, we used a horizontal, open-return wind tunnel to observe the change in velocity and pressure when the airflow is restricted. Air is pulled through the entrance shown in the bottom picture and travels through the contracted chamber, then to the test section where the restrictive plates A and B were installed, and then exits through the diffusing end. The velocity of the exiting air was then obtained through the use of an anemometer and a specialized computer program. Using the dart controller, we increased the speed of the air by turning the knob once. The process was then repeated for 5 rotations, and our team noted the change in velocity and the change in pressure. For control, we first conducted the experiment without the use of any restrictive plates. We then repeated the experiment using plates A and B and observed how the obstructions affected the data we obtained.
The first experiment, we measured the velocity and differential pressure as we increased the speed of the airflow entering the tunnel without any restrictions. The total area of the tunnel measured to be 18 inches. As we increased the speed by rotations, we observed the exit velocity increased and the differential pressure decreased. The second experiment, we used restricted plate A, which consisted of 16 holes with a diameter of 0.215 inches. The total area of the plate is 15.676 inches. As we increased the airflow entering the tunnel by the number of rotations, the velocity exiting the tunnel increased and the differential pressure decreased. However, when the results are compared to the first experiment, we can see the restricted plate slows down the increase in velocity and the decrease in pressure. The last experiment, we used restricted plate B, which consisted of 16 holes with a diameter of 0.12 inches. The total area of the plate calculated to be 17.276 inches. We concluded since the total surface area of plate B is greater than plate A used in experiment 2, caused a greater increase in differential pressure. However, at rotation 4, the differential pressure flew to 0.006. We believe this was caused by human error.
The purpose of this experiment was to utilize knowledge and skills obtained in our Measurements Labs course to demonstrate our abilities to understand, develop, and execute an experimental procedure that produces insightful contributive knowledge. Using the wind tunnel, we were able to observe how restriction of airflow can lead to a decrease in velocity and an increase in overall differential pressure. It seems like an obvious relationship. However, when studying subjects such as fluid mechanics and aerodynamics, its importance cannot be overstated. Fundamental equations such as Bernoulli's equation rely on this inversely proportionate relationship and use the concept to develop a more complex understanding of how fluids behave and how their properties interact with one another. We hope this presentation was informative and displayed the significance of using innovative testing systems such as the wind tunnel.